Hi, I'm Brian Sullivan. I'm a security program manager with Microsoft. And here with me today are Scott Stender, principal partner with ISEC Partners, and Alex Vinegar, security consultant with ISEC Partners. So welcome, guys.
Well, thanks a lot. It's great to be here.
Thanks for having us.
So, tell us what you're going to be talking about at BlueHat.
All right, well, the title of our talk is Concurrency Attacks and Web Applications. And the idea is not that there's this grand new attack that everybody has to be worried about.
No new O-Day you're going to drop.
No 0 days.
Okay.
No, it's about the fact that there's this class of flaw, concurrency attacks, race conditions. They go by a lot of different names. We went for the most high-level general description of them. And that they apply to the web applications world a little bit more than I think the general world understands or should be looking for. So I guess the main idea is that the programming environments encourage these kinds of attacks. And we want to get some patterns for identifying these flaws and hopefully fixing these flaws out to the greater world.
Excellent. So I mean, without naming any names, have you seen this in real life? Do you guys come across this a lot?
We haven't really ironed down specifics on live problems with concurrency.
And we can't talk about the ones that that we often do find.
Right.
You could tell us, but you'd have to kill us.
Yeah, exactly. And all of you, and we don't want to do that. So.
But part of that is because it is a particularly difficult flaw to identify. You might get inconsistent results. If you do the same type of concurrency attack on an application one time, you might not get results. You do it another time, depending on what the servers and applications are processing, you might actually get concurrency flaws or just inconsistent data, which is the sign that there might be a concurrency attack that's successful against an application.
Interesting. So you can't just run the same attack twice and get the same result every time. It could be completely different every time you try it.
Definitely, and that's kind of part of the problem that might not make it an effective means of attacking, but a lot of it is probabilistic and or deterministic. Hopefully, but unfortunately, the results that we got, even on our small-scale servers and databases, we couldn't say that in the classic example of whether you're going to create or destroy money, we could never determine whether the end results after a test were going to be positive or negative for us. So this is an attack that potentially, if you were attacking to gain money, you might actually lose money, in which case that would be bad.
Yeah, well, it would be bad for the attacker, I guess.
Bad for the attacker.
But I mean, it's bad for all of us in that we shouldn't have these vulnerabilities in the code to begin with.
So yeah, definitely the big problem is consistency, and any time that consistency of data is an issue, then whether it's money or resources, things that are going to be created or lost in the digital world, sometimes that's hard to keep track of. So if you can iron out your concurrency problems, then you can iron out consistency problems as well.
Okay. Well, let's talk about ironing out those problems. So are there different remediation strategies for this based on whether you have maybe a standalone server or a farm or anything like that, or is there one best strategy?
It really does come down, just like as Alex pointed out, everything is kind of application specific. And you pointed out a couple of the big scenarios to take into account. Is that if you want to fix at the application layer, you have to be pretty sure that you're constrained to a single server, a single maybe web server with a backend database, and that those are self-contained and nobody else is interacting with them. In that case, you can fix it at the application layer using operating system synchronization primitives. If you are going to a backend database that maybe other people will be interacting with, then you have to, or the best thing to do is to go and push it off to the database and use database transactions to enforce that consistency. And if you have an even more complicated scenario where you might have more than one server involved, then you have to get into distributed transaction management, and that's a very complicated, and expensive from an overhead perspective process.
Okay. So there's different remediation strategies, but is there how can we tell if we have the problem in the first place? We said it was tough to find this experimentally. Is there a way we can just look in the code? Maybe what are some of the code constructs we look for?
Part of actually looking for the problem would be looking at how the data is accessed. So if you have a good model of how data is being accessed by different portions of the application and functions, you can identify whether or not there might be concurrent access issues. And then you can look at how are you protecting that data, whether or not you're using locks at the software or the application level. And once again, you're going to look at whether you're doing it on a standalone system or whether it's going to be a distributed system. So if you have those locks at that application and it's a standalone system, you might be okay. And then you're going to say, well, now it's going to be deployed to a more distributed system. Let's take those locks and put them in a more appropriate place, which is going to be pushed down towards the database level. And then you need to look again at what are the requirements of the data. And if the data needs to be current when it's reading, current when it's writing, just depend on how each portion of the data or how it's important and how current it needs to be for what the application is doing with the data.
Okay. So isn't it true though? If you, I mean, we can apply locks, but this is kind of a tricky operation. Like if you do the locks wrong, you could incur serious performance problems. You could deadlock the app. Is this right?
This is a great denial of service vulnerability right there, too.
Exactly.
So, and that's one of the things that we learned in making our demo apps was finding the flaws is easy. We also wanted to come up with patterns for addressing the flaws, and everything is application specific. Once again, it depends on who all is involved. But one of the approaches that we found that was pretty reliable was to push down the consistency requirements as low down the pipe as possible. So, if we have that front end web server or web servers sharing a single database, we want to make sure that our data is protected using database transactions with a appropriate isolation level. But then, if you just let everything go down there, you're going to hit deadlocks, you can hit denial of service. You might even be able to take out your whole front-end web cluster with a directed attack.
So like the cure is actually worse than the disease.
Yeah, exactly. I mean, you at least keep your money, but nobody can find their money. So what you have to do, the pattern that we did is you can organize your database schema to prevent those deadlocks. Go for it. That's great. A lot of the guidance is all about messing with your schema, reducing your isolation level. You want to make sure, of course, that you keep that consistency in place. But once you're done with that, I found that synchronizing on the front end and the back end was helpful, because at least if you get everybody to be in an orderly line coming through the front, you're not going to have the deadlock issues, and you're going to be able to service these requests in a somewhat performant manner.
That makes a lot of sense. I'm really looking forward to the talk tomorrow.
All right.
So, are there any takeaways for the audience? What would you leave them with as your final thought?
I would say the big thought, one of the big themes that I try to get across here, and maybe you'll have another one, is that these programming environments really do try to abstract away an object-oriented web framework. I mean, tries to abstract away a lot of the complexity, and that you really have to look carefully at those bits of shared data that might be subject to concurrent access. A lot of times, if you do find these flaws, it's something that's pretty subtle. Anything else?
Yeah, just I guess thinking about or adding that class of potential flaw to the process as you're developing an application can help uncover potential risks at the start. And then if you have questions, I would say that talk to your database administrators, and they've probably been thinking about this type of problem longer than you have, and it can be a valuable resource.
Great. All right. Thanks, guys, very much.
Yeah, thank you.